This is the 2013 Honors Pre-Calculus Final Exam Review. We're doing question number 27. Number 27 says to find the exact value of the expression using the provided information. And it asks us for a cosine of s plus t, given that cosine s equals negative 1/2 with s in quadrant 3, and cosine t equals negative 3/5 with t in quadrant 3. So since it asks us for the exact value, we can't really use our calculators to, for example, do the inverse cosine of negative 1/2 and get s and plug that in there, and do the inverse cosine of negative 3/5 and get t and plug that in there. We can't do that because of this little word exact, which is going to be extremely important. We won't get the answer right if we come up with a decimal answer. We need some other kind of answer, a radical answer. So we need to think about this cosine of s plus t, and when we see that cosine of s plus t, that should remind us immediately of a formula that we have, and that formula is that the cosine of a plus b, and some books use u and v, I'm going to use a and b for clarity, it equals cosine a cosine b minus sine a sine b. Now our given information includes that our first cosine, they call it cosine s, but I'm avoiding that s because it's going to be confusing if I have cos s. It'll just look bad. So I'm going to change that variable and make it cosine of a equals negative 1/2, and that's in quadrant 3, and cosine of b equals negative 3/5, and t is also in quadrant 3. So our s and our t, I'm calling s the a and t the b. That's just for clarity. It's a little harder to work with those other two variables. All right, so now I have some information that I can plug in to this formula. I have that the cosine of a is negative 1/2, and I can put that there. And I have that the cosine of b is negative 3/5, and I can put that there. But I have the problem that there are two terms in this formula that I don't have. I don't know what sine A is, and I don't know what sine B is. So that's my challenge now, is to find out what those things are. So in order to do that, I'm going to look at what cosine A is, and that can tell us what sine A is. So I'm going to start by looking at the fact that cosine of A is equal to negative 1/2, and there's a close relationship between sine and cosine because sine squared A plus cosine squared A equals 1, and that's something that we'll need to know for the exam. Now I can take this cosine of A equals negative 1/2, and I can plug that in for the cosine A there, and then I can say that sine squared A plus, and then I'm going to put that negative 1/2 in there for the cosine. Negative 1/2 squared equals 1. Now it's a matter of solving for sine of A. So sine squared A plus, well, I have to work out what 1/2 squared is, and you could use a calculator for that, but again, we want to stay away from decimals because we want an exact answer. So let's think about, well, what is negative 1/2 times negative 1/2? That's positive 1/4, and that equals 1. Now I'm going to subtract the 1/4 from both sides of my equation. So sine squared of A equals 1 minus 1/4, and I know that 1 minus 1/4 is 3/4. Now I need to find out what sine of A is, and I have sine squared of A, so I'm going to take the square root of both sides of this equation, and I have sine A equals, and I have to remember, it's very critical in any work that I'm doing, when I take the square root of both sides of an equation, I'm going to have a plus or minus because there are two different numbers that I could square them and get 3/4. And for now, let's just call that the square root of 3/4. Now let's think a couple of things about the square root of 3/4. First, let's think about the fact that angle A is in quadrant 3. So since angle A is in the third quadrant, which is down here, I know that both the cosine and the sine are negative. So for example, in the first quadrant, the sine and cosine are both positive. In the second quadrant, the cosine is negative and the sine is positive. And in the fourth quadrant, the cosine is positive and the sine is negative. So I need to think about the fact that in the third quadrant, the sine is negative. So that means instead of positive 3/4, I'm going to keep the negative square root of 3/4. Now the next thing I'm going to do is try to simplify that radical a little bit. So sine of A is equal to negative, so I could split this radical up, square root 3 on the top and square root 4 on the bottom. And then I can just do the square root of the top and bottom separately. So square root of 3, I don't know what that is, but I want to keep it as a radical. And square root 4, I'm just going to say square root of 4 is 2. Now, of course, if I had a radical in the denominator, I might think about rationalizing that denominator, but I don't have that. All right, so now I have an important piece of information. I have what sine of A is. It's negative 3/2. So now if I go back up to this formula here and start thinking again about what is cosine of A plus B, and I know that it's equal to cosine A cosine B minus sine A sine B, well, I'm a lot closer to filling out all this information now, because I can say that the cosine of A is the negative 1/2 that we can plug in there. So that's negative 1/2. The cosine of B is negative 3/5, so I can plug in negative 3/5 there. I have a minus sign from the equation, so I'm going to bring that down. Now for the sine of A, I can now put in this negative square root 3/2 that we just calculated. So now my only problem is that I need to know what sine B is. Well, to find sine B, I'm just going to follow the same process that I did to find sine of A. So I'm going to start with my given information that cosine of B is negative 3/2. Cosine of B is negative 3/5 it is. Then I'm going to go to my Pythagorean identity, sine squared A plus cosine squared A. I really should say B at this point. It's really B. Let's call it B. It doesn't matter, of course, but let's be consistent. Sine squared B plus cosine squared B equals 1. And now I'm going to say my sine squared B, that's what I'm looking for, plus, and again for the cosine of B, which has to be squared because it's cosine squared B, I'm now going to put in the negative 3/5. So we'll put the negative 3/5 there. And then we have equals 1. Next step, I can really follow the same things we've done over here. I'm going to square this fraction. So remember, when you're squaring a fraction, you can just square the top and square the bottom separately. If I square a negative, I'll get a positive, so that's positive. And then 3 squared is 9, 5 squared is 25, and that equals 1. Now I'm going to subtract the 9/25 from both sides, so sine squared B equals 1 minus 9/25. Now that's a little bit harder than I had over here. Over here I just got to do 1 minus 1/4, and I can just think about pizzas. If I have a whole pizza, I eat a quarter of the pizza, I got 3/4 of a pizza left. Problem here is I'm doing 1 minus 9/25, and nobody eats 9/25 of a pizza, so you don't have an easy way to figure that out. So what we're going to have to do is get a common denominator for the 1 and the 25. So we'll change that 1 to 25 over 25. So that's just to get a common denominator because I'm adding or subtracting two fractions. I need them both to have the same denominator. So the 1, I rewrote it as 25/25. And then I can say that sine squared B equals, now I can just subtract the tops and keep the bottoms the same, so I get 16/25. Next step, just like over here, is take the square root of both sides. So I'm going to take the square root of this side and the square root of this side. And when I do that, see, each time I took the square root of sine squared, I got sine. So I'm taking the square root of sine squared. The square root and the squared are inverse operators, so they cancel each other out, and we just have sine of B. But I have to put plus or minus, and now I need square root of 16/25. So I can just do the square root of the top and bottom separately. Square root of 16 is 4. Square root of 25 is 5. So it's sine of B equals plus or minus 4/5. Now again, I have to think about that quadrant. So in this problem, I saw that I was in quadrant 3, so the sign must be negative. In this problem, well, they told us the angle, in the way the problem was worded, it said angle T, but we're calling it angle B. It says the angle T is in quadrant 3. So again, in quadrant 3, if I look at the sign is negative in quadrant 3, so I'm going to take the negative 4/5. So now I know that sine of b is equal to negative 4/5. And now, just like I plugged this negative square root 3 over 2 for the sine A, I can plug this negative 4/5 in for the sine of b. So now I have times negative 4/5. Now I'm not done yet because I have to simplify this, but I've done the hard part of finding out separately what sine of A. I was given cosine of A, but I needed sine of A. I was given cosine of B, but I needed sine of B. Because this formula calls for 4 pieces of information, but they only gave us 2. So all of this work was to turn this one piece of information into a second piece of information that we could plug in there. And all this work is to turn this piece of information into this second piece of information. So now I have 1, 2, 3, 4 values that I can plug into my equation. Now I'm going to just go through the simplifying the fractions. So negative times a negative is a positive. Remember, you just multiplying fractions, we just multiply straight across. We don't get common denominators when we're multiplying fractions. So 1 times 3 is 3. 2 times 5 is 10, so that's 3/10. Now over here I have minus a negative times a negative. So I have 3 negatives, that's going to come out to a negative. And now I'm going to multiply straight across. Well, I could make my work a little bit easier by reducing the 2 and the 4. You don't have to do that right away, but we could do that. So this is 2 and this is 1. And now I just have square root 3 times 2 over 5. So let's write that 2 square root 3 over 5. So what happened there, we reduced the 4 and the 1, got 2 and 1. 2 times the square root 3 is 2 square root 3. 1 times 5 is 5. Now, a lot of people would consider this to be an adequate answer. Let's go one step further and simplify it. Since 10 and 5 have a very close common denominator, we could get a common denominator for them, which is 10. So let's put this one over 10 by multiplying the top and bottom by 2. So we're going to multiply the top and bottom by 2 times 2 times 2. And then we get 4 square root 3 over 10. And that allows us to put the whole thing together into a single fraction as 3 minus 4 square root 3 over 10. And that's our final answer. This one would probably be acceptable. But you know, if it were a multiple choice question, the answer might be this way. So if I got this for my answer, I would look at the multiple choice answers and I wouldn't see that answer there. That's why it's a good idea to be familiar with simplifying so I could get the simplest form of the answer. And that's number 27.